Welcome to this introduction to the second exercise of our HVDC training course. Since this is quite an involved course, so we decided to make this little recording to show you how to set up everything and make sure that it works fine before you start taking readings in your system. So as the exercise suggests, you should set up the modules in the console in a certain way to limit the amount of wires, the length of the wires required, and to make it easier to understand. So we will be using our power supply module here, which will be used for both the bridge 1 AC side and bridge 2 AC side. So we will use the fixed output for the bridge 1 and the variable output for the bridge 2. So this will be our power supply on both sides of the HVDC system. Then on the left side of the console, we have everything pertaining to the converter station 1. So the regulating auto transformer, the three-phase transformer bank, and the thyristor bridge that will be used on the converter station 1 side. And on the left, on the right here, you will have the modules pertaining to converter 2. So regulating auto transformer, three-phase transformer bank, and power thyristors. Between the two, we have the transmission line module, which will be transferring the DC power from one bridge to the other. And then we have also our two data acquisition modules. This exercise is so involved that it requires two data acquisition modules. And as we will see, the software asks you which one is which, and you need to identify them using their serial number. So we have the serial number on this sticker here for each modules, and we will see how to set that up in the software. So now if we look at the exercise itself in the manual, we are here at exercise 2 in the HVDC course, as I was telling you. So it goes in length as to explain how these devices work and how to configure them to get our operation point set at the right location for our needs. So I skipped this theoretical portion to jump directly into the procedure that we will do together. And as I was telling you, this is only an introduction, so we will only do the first two parts of this exercise here, the setup and connections and the basic operation of the HVDC transmission system, just making sure that everything works as planned. So here are the suggestions of where to install the modules. Then to turn on to make sure that the power supply is off, connecting the 24-volt AC power source on our data acquisition and thyristor module. So this is already partly done here. So we take the 24-volt AC output of our power supply here, two lines, one going to this DAC and the other one going there. As you can see, they are already powered. And we just need to add two more power lines to our thyristor modules. So this guy, I will power thyristor module here, and this one here, I will be powering this one. We are also requested to connect the control signals cable between the DACs and the corresponding thyristor module. So this DAC will take care of controlling the converter station 1, which is implemented with this guy. So we will go from this station here to this module, to this thyristor module. And this upper DAC here will be connected to the other thyristor module here. Okay, so if we go back here, they ask us to connect also the USB cable of the data acquisition modules to our computer, which is already done. and start the LVDAC-EMS software to make sure that the two DAC keys are connected. But if you don't mind, in our case, we will jump directly to the converter station 1 schematic to start doing these connections here. So as we see, each station is composed of a regulating autotransformer, a three-phase transformer bank, and the power thyristor module. So this is converter station 1, and we'll see that converter station 2 is exactly the same, except in reverse order from left to right. And also notice that on both sides, we will need both the three-phase lines, 1, 2, 3, and the neutral connected to the autotransformer. And the other side of the autotransformer will have line 1, 2, 3, and the neutral connected to our three-phase transformer bank. And our three-phase transformer bank module will be connected in a star-star pattern. So both primary and secondary are connected in a star pattern, and then we will get into our meters. So let's start doing these connections here. I will start by using these optional three-phase cables just to limit the amount of cables visible in the station. So to connect the fixed AC output of my power supply to my first regulating of the transformer here. Of course, you can use 3 separate wires to do the same. Just here to visually limit the clutter. So here, plus an additional wire. Let me put these wires around my neck. Here, additional wire for the neutral, as I was showing you in the schematics. Same thing for the other converter station there. Three-phase power, this power supply to the other regulating of the transformer here, and the additional wire for the neutral. Good. Then from our transformer, we will go to the three-phase transformer bank here, and these require a bunch of short wires to wire in a star-star setup. So that's what I will do now here, the primary being the left units here on each of my transformers. I will connect the 2 with 7 and the 12. Have the primary in a star pattern, and same thing for the secondary, 5, 10, and 15. And while we're at it, let's do the same on the second transformer here. 7, 12. 5, 10, 15. Good. So if we go back to the schematic here, we will see that we want 4, 5, and 6 of our auto transformer to go to 1, 6, and 11 on our on the primary here. And then on the secondary side, we will want our 4, 9, and 14, which you will see are not the maximum voltage one, but the tap in the center here. 4, 9, and 14 will go to, well, 4 will go to I1 to measure the current in this phase before going to bridge 1. And we will have E1 and E4 also connected on each side of I1 to measure the voltage between line 1 and line 2 here. So let's connect 4, 9, and 14 to our thyristor bridge going through I1. 4 here, go through I1. From there, we'll go to thyristor bridge. Note that the thyristor module need to be set as in the exercise with the two switches here set to on. In this case, it means that we have these 3 points connected together, these 3 points together here, and this is also connected like this. So it makes the three-phase connections much easier. So I1 will go to phase 1. Of course, any of these two ports will do since they are connected together. And then the other phases will go directly to the thyristor bridge. So 9 will be connected here, 15 here. Now we're just left with the voltmeters to be connected. So we see positive of E1 to positive of I1, and the negative goes to line 2 or 9 of our transformer. Positive of E1 goes to positive of I1. The negative of the positive of E4 goes to the negative of I1. And then 9, which is here, which is phase 2, goes to the negative of both. This. We're done here. And then we get into the bridge, and the output of the bridge is A1 and A2. So this is our DC output because the bridge acts as here a rectifier, taking the three-phase AC voltage, converting it to DC output. So A1 and A2 here flows into the next schematic here for the DC transmission line. So A1 and A2 comes here, and first A1 needs to go through I2 to measure the DC current flowing in our transmission line. So if we go back here, A1 is the top of our bridge here. So A1 goes to I2, and I2 to the transmission line here. The A2, which is the negative here, will go to our neutral here on our transmission line, and these 2 points are connected together. So it's just for convenience. On the transmission line, you need to make sure that the switch is on to let the current flow and to set the impedance of your line to the appropriate value for the voltage in your country. Here we are in Canada, so it's 120 volts. And the manual asks to set the impedance to 60 ohm here, which I had it set to here. The last thing to connect on the transmission line is E2. So the negative of I2 will go to the positive of E2. Here. So basically E2 will be measuring the voltage, the DC voltage that we have on our transmission line. Good. Now let's move to the last portion of the schematic setup for converter station 2. So here you will have to be careful, and this is one of the common mistakes in this exercise, is the polarity is a bit confusing. So as you can see here, bridge 2 is connected reverse to bridge 1. So A3 will be going basically to the anode of our thyristors instead of the cathode, and vice versa. Same thing for the meters here. We will have to be careful. You see that the output of phase 1 of bridge 2 here goes to the negative of I3, not the positive. So this is also reverted in terms of polarity, as everything is here. So here we are connected at 4, 9, and 14. So basically it's everything that is swapped horizontally compared to what it was in the preceding schematic. And we are getting out at 1, 6, and 11 to go to 4, 5, and 6, which is on the right side of our regulating autotransformer, and then 1, 2, and 3 going back to the AC power line. So let's go into our bridge 2. A3 will go to the anode. A3 here goes to the anode. This goes up here, the cathode, and again, our two switches are on here. And we have the output of phase one going to the negative of I3, which will then go to 4 of our three-phase transformer module. So phase one, negative of I3 here, and the positive goes to 4 here on our transformer. Then the other phases go to 9 and 14. Let's finish with these meters also here. So the positive of I3 goes to the positive of E3. Positive of I3 goes to the positive of E3. That's quite busy. And the negative of I3 goes to the positive of E4, except that if you see here, the positive of E4, but the E4 is shown in red to indicate that this E4 is from the second data acquisition module, because the E4 in the first data acquisition module is already connected. So this goes to the positive of E4 on the second data acquisition module. So from the negative of I3 here to the positive of E4 on this module. And then here we can see that the negative of E3 and E4 both go to line 2, which is 9 on our three-phase transformer bank. The negative of E3 goes to 9 here. This is shared also with the negative. Sorry, mistake here. So this goes to positive and this goes to negative. Good. So you see how easy it is to make a mistake here. And of course, this would have caused a problem because this E4 is used to synchronize the firing angle with the phase of the AC on the second bridge. So if I reverse the polarity here, the synchronization would be reversed and nothing would work. So this simple mistake I made here could create a big problem. So make sure to respect the polarity of these schematics. So this is all done. Now let's go to 1, 6, and 11 of our transformer to go to the regulating auto transformer. One goes to 4. 1 goes to 4. 6. 5, 7 to 6. And then we want to make sure that our neutral is also connected. So the neutral of our regulating auto transformer is connected with the neutral of our primaries. So 12, for example, the neutral here is connected to 12. And then this neutral has already been connected, so this is good. Are we missing anything? Let me make sure, because I'm left with a lead in my hand, wondering if I did not forget anything. So we have the 3-phase here, we have the DC here, 3-phase, this is connected in Y. Here I'm not missing anything on any of these outputs and outputs, you know. And this here is good. 3-phase, the DC output going here. Everything seems, no, there you are. I missed the neutral here. So the neutral on this side, I'll be regulating at the transformer of the first bridge. If we go back here, the neutral should be connected to the 12 here. So you see, I have missed another connection there. Really easy to forget one. There you go. So this is complete. All in all, 34 of these yellow leads are required to do the connections like this. So this gives you an idea of how involved the exercise is. Okay, so now if we go to the manual. Oops, sorry. So this is our software here. If we go to the rest of the exercise here, they ask us to now configure LVDAC-EMS with the function dual thyristor bridge and with certain parameters to start with. So the firing angle of bridge 1 controlled by the knob and set at 75 degrees, the control angle of bridge 2 controlled by the knob and set initially at 165. That's it. And then also to set up the metering window to measure the AC and DC voltages throughout the system, as well as the currents and the power, active and reactive power, and the power factor on both bridges also. So, and finally, configure the data table to record all of these parameters. So if we look at the software where I have already pre-configured all that, we can see that on the HVDC Transmission System control window, we have the dual thyristor bridge function selected here, independent as required. Then we have the bridge 1 controlled by the knob set at 75 initial value, and bridge 2 controlled by the knob set at 165 for the initial value. You will also notice that the serial number of these two data acquisition modules appear here. And you will see that when you first start the software and start configuring this function, the software will ask you which of the two DAC keys connected to the computer is used for the HVDC and which one is used for the computer instrumentation. So this is where you will specify these serial numbers. So this window is ready to go here. Then on the metering, I have separated the meter window here in two sections. So on the left side is everything pertaining to bridge 1. On the right side, bridge 2, and in the middle are DC transmission lines. So you can see that this is DC voltage and current and the power factor. While on this side, we're all in AC. So we're measuring the voltage at the input of the bridge, the power, active, reactive power out of the bridge, and then the displacement power factor, and the same thing on the second bridge side. Perfect. So we're almost ready to go. If we look at the exercise here, we are in the section where we start looking at the basic operation. So initially, they want us to launch the power supply and check what we get basically with in terms of voltage in our software. So, and we will slowly decrease the firing angle of bridge 1 to 0 degree to see what is the maximum voltage we can get on the DC line. So let's do that now. Let's switch to the software again. So you can see that initially we have 0 on the DC line, of course. Now I will start the power supply here. Okay. And if we go back to the software, you will see that now we have 120 volt on both sides of our bridges, but on the DC side, we still have nothing because, of course, the function has not been started yet. The thyristor bridge is still off. So now let's start it with these initial values of 75 and 165. And you will see that as soon as we do that, we get a voltage of about 40 volt here in North America to start with on our DC line. And the current flowing on the DC line is null. Now, according to the exercise, we slowly decrease this firing angle on bridge 1 here. And you will see that as we do so, we can see the new value of the firing angle, 65, and the voltage is increasing here as we decrease this firing angle. So I go slowly using the arrow here. You can see the voltage is now at 100 volts, DC volts. Keep increasing the firing angle, decreasing the firing angle, sorry, down to 0. And when we reach 0 for the firing angle, we are at our maximum voltage on the DC line, 160 volts. Yet there is almost no current flowing through on our DC line, on our transmission line yet, because the voltage on the firing angle on bridge 2 is too high and maintains a too high a voltage to allow any current to flow from bridge 1 to bridge 2. So the next part of the exercise asks us to bring back this firing angle on bridge 1 to 15 degrees, which is a typical value used in the power industry to give us some leeway around above and below this firing angle to control fluctuations on the voltage on the AC network. So now we have a voltage of 154 volts, and now we will start decreasing the firing angle on bridge 2 to allow some current flowing. So you will see that as soon as I start doing this, we will get DC current increasing here, okay, on our transmission line. And the exercise asks us to do this until we reach the maximum current presented in the table here for our network voltage. So here in North America, 120 volt, the maximum current we should reach is about 1 amp. So I will decrease my firing angle until on bridge 2 until we get a current of 1 amp here. Let's do that here. So you should hear also your thyristor bridge whining a little bit because now there is current flowing through it. So here I am about at the maximum current, and my firing angle is now at 144 degrees on the second bridge. And you can also see that now there is power exchange between the two converter stations. So bridge 1 is providing 152-55 watts of active power, 44 VAR of reactive power for a displacement power factor of 0.96, which is really good, above 0.95. On the other side, we are receiving 138 watts of active power, so some losses in the transmission line, of course. A lot of VARs, also 100 VARs on this side, which gives us a displacement power factor of 0.81, which is not good. And part of the exercise is to explain how to prevent this value to become too low by preventing the firing angle of having to become too low for the current to flow. So basically, we will play with our taps on our transformers to reduce the voltage on one side or the other to allow power flow without having to decrease too much the firing angle. So all in all, we can see that this is working really fine, and the values we get here are really close to what is expected in the exercise. So if we look in the table here, we see that for a DC current of 1 amp, we should have a firing angle of 145 on bridge 2. We are really close to that. A DPF of 0.96 on the first bridge and 0.82 on the second bridge. So all of these values are perfectly in line with what we see in the software here. From there, the exercise simply goes to having you take readings at different current values for different values of the firing angle, and then playing with the power flow in the system by using the taps on these auto-regulating transformers to reduce the voltage in one bridge and have the power flow in one direction or the other. Be aware, though, that the way the system is set, the current will always flow in the same direction. In this system, the DC current will always flow from the converter station 1 to converter station 2. So the flow of current is always in this direction, but then with the firing angle on our bridges, we can change the polarity of the voltage. So the voltage will be positive or negative, and based on the polarity of these voltages, we will have power flowing this way or power flowing the other way. All of that is explained, of course, in the exercise. So thank you for watching, and see you in another exercise like this.